Broadcasting live from our studio in Boston, Solutions Review is proud to showcase Monte Carlo and the Solution Spotlight, a unique online event for industry professionals.
I'm Doug Atkinson here in Solutions Review, and welcome to this Solution Spotlight featuring Monte Carlo and focused on architecting for data quality in the Lakehouse. From null values and duplicate rows to modeling errors and schema changes, data can break for millions of reasons. To combat this, teams are increasingly adopting best practices from DevOps and software engineering to identify, resolve, and even prevent this data downtime from happening. In this session, we will walk you through how to solve for data quality across the data lakehouse and discuss how data engineers early on in their lakehouse journey can optimize data reliability across metadata, storage, and query engine tiers. You'll also see how teams can take governance and reliability a step further by integrating common approaches to data observability, including setting SLAs for data pipelines, monitoring a data downtime impact radius, and using field-level lineage to root cause data issues. Needless to say, this spotlight is packed, so let's get into it. And joining us at Monte Carlo in San Francisco is Prateek Chawla, founding engineer, and Itay Bleier, head of engineering. Gentlemen, thanks for being with us.
Thank you for having us.
It's great to be here. Thanks.
Well, we were looking forward to this particular spotlight for a while now. I think we've actually had this one on the schedule for some time and actually have a pretty amazing turnout. So there are a lot of people interested in digging into it. But before we get going, I'd love to hear just a little bit more from each of you about your backgrounds. Prateek, you're clearly an expert engineer, but tell us a little bit more about yourself and how you've come to be here at this event.
Yeah, sure. I'm happy to do a quick intro. So I'm Prateek. I'm the founding engineer, or one of the founding engineers and lead at Monte Carlo, where I help drive the technical strategy for our data observability platform. Previously, I was a technical lead at Barracuda, where I worked on email fraud prevention technologies. And I graduated summa cum laude with a BS from computer science and engineering from UC Santa Cruz. I'm excited to chat data.
Excellent. Well, we're always excited to have experts, and for this event, we've got a couple of them. Itay, I know you're going to start the presentation, but before you do, please tell us a little bit more about yourself.
Yeah, absolutely. Thank you, Doug. So I lead engineering at Monte Carlo for the past 4 years. So pretty much from the day we started at Monte Carlo. So you could say I'm pretty much addicted to the early stage kind of startup world, where before that I was at a different startup, Casa, which got acquired into Barracuda Networks. Actually did a bunch of work in the security space for a few years. And if we go back even more, I started my career in software engineering actually in the Israeli Army, IDF, working on different systems. And so I had just a great time the last 4 years at Monte Carlo, seeing how we can grow this data observability category from the ground up.
Yeah, great. And we've been following Monte Carlo for some time now here at Solutions Review, and have done more than a few of these spotlights and really dug into a lot of these key considerations that folks really need to be thinking about with regard to data observability and all the other issues around data architecting. Before we get into the presentation, I'll set everybody's expectations around how this event's going to go. We're going to let Prateek and Itay go for as long as they want, ultimately. And then when they wrap it up, I'm going to jump back in. I'm going to have a series of questions that I'm certainly going to want to go through, and then we'll end the session from there. So Itay, I'm going to turn it over to you, and I'll let you get your presentation ready, which it looks like it is. Outstanding. And I'll talk to you at the end of the session.
Thank you, Doug. All right. So after this great introduction, let's just dive into architecting for data quality in the Lakehouse, and tell you a little bit about our journey. And so we've kind of skipped through this, given that we've already talked. I'll just mention that Monte Carlo really created the data observability category a few years back. And we'll do our best at kind of explaining what is data observability all about and what problems it is meant to solve. So a little bit about today's agenda. We're going to talk a little bit about just generally about data observability. Then we're going to dive into applying the observability specifically in data lakes and lakehouses. We're going to share some challenges that we've come across and some of tips from our own experience. And we're going to showcase our Monte Carlo Databricks integration to you. All right, so starting really with the basics. So before we can talk about data observability, we do need to talk a little bit about data downtime. So what is data downtime? You can see the definition here. It is data downtime refers to periods of time where your data is partial, missing, or in any way inaccurate, really. And why is it? You're probably asking yourself, is it a real problem? And you can probably think back to instances where you or your team experienced data downtime. A couple of like pretty famous, well-known, publicly available examples of data downtime. So Netflix was actually down for 45 minutes in 2016 due to duplicate data, which is pretty insane if you think about it. A platform of that size incurring such significant downtime because of the data issue. And more recently, the company Unity actually misspent around $100 million on ads due to bad data. And so repercussions of bad data are actually really significant, right? And thought I would share an example from our own experience. Even when we were pretty early stage, we were using PySpark, and we made a pretty naive schema change that we didn't think would cause any real issue. But it actually turned out that because we were relying on a specific field in an inner join operation downstream, what ended up happening is that inner join produced a lot less data. And so we basically had a lot of data dropped at that stage, which caused a data downtime incident for our team. So you can see how easy it is actually with naive changes to create data downtime incidents for your team. And so we talked a little bit about a couple of examples where to showcase how real data downtime is. But if you think about it, companies are increasingly relying on data to make decisions, to report on their earnings, right? Reports that CFOs, CEOs are using on a daily basis to make decisions. And so it is increasingly important that data can be trusted. And to really achieve stakeholder trust, data teams really need a comprehensive understanding of their health and performance of their data within their ecosystem. And that means understanding pipelines and orchestration, things like Airflow and dbt, and understanding schema and tracking code changes, and also understanding their consumers, specifically BI, right? How is the data actually used downstream, right? And so for that reason, data downtime is a really important problem for organizations that are increasingly relying on data to solve. And why is it hard, right? So practically, it's impossible to really predict all ways in which data can break. And this kind of reminds me also from my own software engineering background. It's the same for software. It's just pretty much impossible to think about every possible scenario that might break your software. Same with data. And especially as data volume grows, the ecosystem grows in complexity. It is harder to predict ways in which data will break. It is also much harder to assess the impact of something breaking for any individual data engineer. And so here comes in basically an operational approach to reliability. And both Prateek and myself are kind of coming from a software engineering background, and we've been super excited, kind of dipping our toes in data and data reliability. But a lot of the same principles actually apply here. We want to detect quickly. We want to alert the right individual or team. We want to resolve issues as quickly as possible. And we want to learn, evolve over time, and be able to prevent some of these things that have already happened to us. And in engineering, we look at different metrics, such as CPU consumption, memory usage, latency, right? And we track these things. That is all part of observability for software. And we have other pillars like traces and logs that are there to help us triage, debug, and resolve incidents more quickly. And as a software engineering team and also as a data engineering team, we want to know when something breaks or misbehaves before customers report it to us. Nobody wants to learn about these problems from customers. I want to be on top of it. We want to be the first one to be alerted when something might be happening. And so really it's the same for data teams, just as it is for software engineering teams. We want to be proactive. We want to be a step ahead of the problems and be able to also address them and resolve them as quickly as possible. And so here comes data observability, right? Very similar to what I just kind of described for software observability. Data observability is really not that different. We want to detect, and detection could mean ML-based anomaly detection. It could be rule-based, right? I might know exactly what I'm looking for. There's a certain SLA or SLO that I know I want to uphold. I want to target the individuals that actually need to know about something, right? Those workflows in a larger organizations could be really, really tricky. So we want to be able to let the right person know, get the notification in the right hands. And then we also want to be able to resolve and resolving, triaging and resolving an incident. What that means is we need to be able to first and foremost understand impact. Like impact assessment is critical in understanding whether this is a Sev zero, something we have to drop everything else and chase this down, or is it something that could wait a day or two? And who are the impacted consumers? We want to let them know about it. We want them to be aware that there's an issue we're working on. So again, that proactiveness. And so that's a big part of the resolution workflow. And another is root cause analysis. We want to be able to understand where the problem is coming from, and tools like field level lineage, which we'll touch on in a bit, are again super important. Tracking code changes, schema changes is another way of understanding the incidents and getting to resolution faster. And then lastly, like one other thought is prevention, right? So we do want to get better over time. We want to prevent similar situations from recurring. And so there are some tools that can be applied towards preventing that same incident from happening again. And so we're going to dive into data observability pillars, right? There are 5 of these, and I'm going to touch on each of these to kind of showcase what comprises data observability. And so the first pillar, a pretty basic one, and I would say an easy one to kind of comprehend is freshness. So how up to date is the data that we're using, right? Stale data is super risky to use, right? Best case, we know that we're using stale data and we're taking that into account. Worst case, we are not even aware that we're using last week's data to make decisions this week. So that is super important. How often and how regularly our data gets updated and knowing when something is off. The second pillar is volume, right? So tracking volume over time means we can understand whether there's like a big drop in the volume of our data set, which could indicate a problem, maybe an accidental deletion, or if there's a spike, could definitely indicate duplicate data, right? So we want to understand whether this data is grows over time in a pretty stable way, and then if it's misbehaving, we want to know about it. Our third pillar is quality, right? So this looks at different aggregated statistics of the data. So we could think about things like the distribution of allowed values, right? Maybe I have a field that represents a US state, and there are specific values that are allowed. And there are also a distribution of those values. Maybe there's more values, 50% of the values might be for one given state, right? And so we want to know when drastic changes occur in that distribution. Other examples is null rate or uniqueness rate. So for example, a field like order ID that's supposed to probably be 100% unique. All of a sudden, if there is a drop in uniqueness rate, meaning there are duplicate records there or like duplicate values of the same order ID, we want to know about it. This could really easily break downstream consumers in very unpredictable ways. And then the fourth pillar is schema. So the way I think about schema is kind of like code changes. We are making a lot of changes, and many of them are legitimate, and we intend to make them, but they're still good to know about because they could relate to incidents that happen afterwards. And it is extremely useful to have that context when you're triaging an incident. And also there are some changes that are not intentional, right? And then we want to be able to really quickly figure out whether this relates to an incident that the team is kind of working through. And so it could really be key to understanding incidents. And the last pillar, and certainly not least the least important one, is lineage, right? The first question that teams often ask themselves is where the data broke. Okay, where is the data coming from? Understanding root cause, tracing the problem backwards to the root and solving for it as quickly as possible. And also, where is the data being used? Understanding impact. And we talked a little bit about it, understanding whether it's a step zero, everyone needs to be all hands on deck, we want to fix this incident, or is it something that could wait a couple days or a couple hours, right? So lineage really kind of brings all of this together and allows you to understand your pipelines, your data ecosystem, and trace problems, even at the field level, right? So if I have a problem and I'm looking at a specific field, I can trace and see where that field is getting its values from upstream, right? And then I can also see, is it really being used by consumers, or is it a field that's more of a nice to have, right? So this is an extremely useful tool when working through incidents. And I'm going to hand it over to Prateek now to talk about applying observability in the Lakehouse.
Yeah, thanks so much, Itay. So like you mentioned, we're going to talk a little bit about applying observability to data lakes and lakehouses and kind of talk about how to more practically use the 5 pillars. So the first one is freshness. So with data lakes, measuring freshness at scale really requires collecting events from the storage layer and stitching them with metadata about table location, and also using metadata in more asset-compliant formats like Delta. So what this really is a combination of data sources, and this is especially the case for formats like Parquet, CSV, JSON. One approach you can take is you collect the table and partition locations from the metastore, and then you collect update events from the storage layer and stitch them together. Let's say you're using AWS. In this case, your data will most likely be living on a blob storage layer like S3. So what you could do is from the metastore, you could collect the bucket and path or prefix information, and then leveraging a technology like S3 events or EventBridge, you could in near real time track changes to the underlying data, like when new objects are added or removed. And once you find an object that correspondingly is, let's say, added, you can kind of match it back up to the specific prefix, and then you can say this event was associated to this particular table. And then that way you can kind of get changes in your underlying data based on the storage. Now, of course, if you're using a format like Delta, and you probably are if you're building a more modern lakehouse, the approach is a little bit more similar to your warehouses and requires, it's also a lot simpler. And this is primarily because the storage layer events are insufficient because they don't really map directly to changes in your underlying data. A good example of this is when you're using Delta, vacuum events happen. That doesn't necessarily correspond to your data changing. But luckily, we have the describe detail command, and it kind of gives us most of the information we need. So on screen here, you can see on the left an example from S3, and on the right, the schema from describe detail. Okay, so now quality. So with data lakes, you can leverage Spark SQL or another query engine like Athena, Presto, Hive, pretty much kind of depending on how you've set up your lake. And of course, if you're using Databricks, you can leverage SQL warehouses or periodic jobs. And these queries can be more reactive and kind of alert when thresholds are breached, or a little bit more proactive and can actually be used to circuit break pipelines. And that's not really orchestration tool dependent, so you can definitely use like something like Airflow, dbt, or even the native scheduler in Databricks. So basically, if your data doesn't meet your requirements, like let's say between transformation steps or after like an ELT job, but before BI dashboards are updated, you can know about it and take specific action. And more specifically, quality data can be collected via some different mechanisms like SQL sampling, and there are a range of queries that you can run based on the type of data. So on slide here, there are a few very simple examples, but you can kind of monitor for multiple things. Like Itay mentioned, %null, %0. You can check also if, let's say, two tables are identical record for record, or maybe have the same number of records. You can kind of create these queries to fit your business needs, basically. You have the flexibility to come up with essentially anything. Okay, let's touch a little bit more about volume. So with data lakes, measuring volume at scale requires collecting events from the storage layer and stitching them with metadata about table location, and using metadata in ACID-compliant formats like Delta. Now that sounds probably very similar to what I said about freshness, and the truth is, it is very similar. It does rely on a combination of data sources, like for formats like Parquet, CSV, and JSON. You collect your table locations from the metastore, and you collect update events from the storage layer, and you stitch them together. Now, the one key difference here, though, is that this will only give you write or changes to the size. We call this write throughput. So basically, if a file is added or a file is removed, it doesn't actually give you total volume. If you want total volume or total size, what you actually need to do is probably bootstrap that by creating an inventory, and then you can compute the differences over time. Not saying that's necessarily the approach you need to take. There are cases where you want the total size and you want to see how that changes, but oftentimes even just measuring write throughput is sufficient because you're looking for pattern changes. And again, with Delta, the approach is a little bit different, and for the same reason as freshness, the storage layer events are not really sufficient because they don't map directly to changes in the underlying data. But again, once again, we have the describe detail command, which kind of gives us what we need. And on screen here, you can see examples of both an event from S3 and an event and the schema from describe detail. All right, so with schema. So especially with data lakes, keeping track of changes in schema is very, very important. Here, you'd want to track the previous schema for each table and compare it to the current schema. One easy way you can do this is compute the hash of every time you collect schema. Let's say you do this on an hourly cadence, or maybe you do it twice a day. Doesn't really matter how frequently you do it, but you can collect the current hash, and the next time you run, you collect the hash once more. If that's different, then you know some sort of schema changes has occurred, and then you can diff the two to determine whether it was a new field added, a field removed, or a field change in some way. Of course, this varies very much based on the metastore you're using, but at the most basic level, you can kind of still leverage the Databricks describe table commands or the information schema if you're using Unity. And if you are using another metastore, like let's say Hive, like an external Hive or Glue, it might make sense to actually connect directly and batch such operations. In addition, when you're working with lakes, and if you're dealing with semi-structured data, one other consideration is that you probably want to also monitor for changes in the underlying data itself here. So instead of just the schema, which is the structure of the table, like the different fields and columns, you could consider monitoring if, let's say, a new key is added to a specific field, or a key that you expect there to exist gets removed through some sort of sampling technique. All right, now lineage. So measuring lineage at scale requires collecting and parsing SQL logs and integrating with the UC lineage APIs for Spark-based jobs. Effectively here, like with most things in life, the more sources you can use, the better. So it's important to consider both the table-level lineage, which includes lineage across platforms like BI, and field-level lineage, which is more granular and precise. So the former gives you the ability to get a quick bird's-eye view of your data platform, and is great for context and discovery. Especially like, let's say you're training a new hire or you're introducing someone to your data platform. A great way to introduce them to the platform itself is to show them how the different things are connected and what's a key asset and what's not. And then with column level lineage, you can make some more additional insights, such as impact assessment and root cause analysis. There's lots of different use cases for it. And one of my favorites is you can actually use column level lineage to make better determinations. So let's say you want to deprecate a specific column. How do you know if it's safe to deprecate it? Column level lineage will help you because it'll tell you exactly what are the downstream resources that are using this specific column. Or let's say you're triaging an incident and that there's a high % null for a specific field. You can go upstream and you can see if there was something correspondingly changed in one of those tables that is used to build this specific build or update this specific column. So you can kind of use this to make a little more informed decisions kind of in both directions. Okay, now I wanted to touch a little bit about various different data quality challenges and tips. So first of all, each metastore or kind of source of truth for a lake is different, so monitoring it should be too. Data lakes typically have multiple different technologies involved, and oftentimes these are mixed and match. It really boils down to the way data is structured, as well as the various entry points a lake can have that most warehouses don't. So this entails different things like metadata, storage, query engine, query logs, and lineage. And applies both at the pillar or job and source of truth. And this table here on the slide kind of summarizes some, and definitely not all, of the different options you can leverage, because it really varies on what your lake looks like. Let's say you're starting out though, like at a smaller scale. It might just make sense to pick one, like start with Spark and go from there. But of course, as you grow and you want to expand, you do want to consider scale and the various different data sources. And then one tip is consider multiple separate jobs, kind of regardless of the interface you decide to go with, especially if you're working or to migrate to UC, as they each kind of have their own scalability limitations. And then, of course, if you are in UC, leverage those APIs while you can, or where you can, sorry. Okay, let's talk a little bit about scaling observability. So metadata collection is not really the usual workload Spark was intended to handle. From our experience, we found it doesn't scale well with a number of workers and has diminishing returns from vertical scaling. Effectively, what happens is the driver kind of gets saturated with these various different metadata operations. What you're doing oftentimes is just effectively scanning a transactional database that's not directly accessible with queries that operate in the magnitude of seconds. Now you might ask why the magnitude of seconds is important. That seems fast enough, right? But you have to think about it from a scale perspective. If you have 50 tables and you need to collect this once an hour in each query, and each one takes a second, no problem. Now, if you have 100,000 tables, you're pushing the boundary of that of your ability to collect it in a reasonable amount of time. So it's very important to consider those things. And so to that end, it's very important to also consider connecting directly when you can, or leveraging like the information schemas or APIs and UCs to kind of maximize the number of batch operations you can take. Another approach could be scaling by discrete job, both kind of within a data set and operation type. One thing is that metadata and queries kind of often have different size requirements. You probably won't need the same cluster to run metadata queries as you would to do like quality-based queries, because they have one generally operates in the same order of magnitude, and the other one kind of scales based on the actual data set. And if also you know that there are specific schemas that are core or critical, you can consider starting with those. Or maybe consider just starting with Delta tables to help kind of simplify all the different tentacles you need to manage. If you just focus on Delta, for example, maybe you don't need to worry about the storage layer itself at all. And that's a simpler approach to start with. And of course, when you compute something that's unlikely or infrequent to change, consider caching it, either like in a new table or use an actual cache. So you don't need to recompute data that has to be crawled at a very frequent cadence to build patterns or insights. A good example of this is, let's say you make different decisions if something is a delta table or not a delta table. A table going from delta to non-delta or vice versa is likely to infrequently change. So that's something you consider caching. Or maybe you can cache the schema for a longer portion of time, because let's say maybe you don't need to collect it every hour like you would need to for like freshness or volume, where the schedule and timing is more important, and you can consider doing that maybe twice a day or once a week or whatever fits your specific business needs. And of course, this also allows you to run particular queries when something has changed. So if there is a shift, then run a specific query. Otherwise, you can use the old result. And then, of course, kind of varies based on what you're trying to do. So let's say, for instance, with volume, it's actually surprisingly row count scales pretty well, because that's kind of what Spark was meant for. So previously, when we were talking about volume, we were talking about bytes, and that's kind of what you get back from the delta log. But again, Spark was designed to run queries, right? So if a row count's like a simple select star count, actually sometimes this is not bad from a performance perspective, especially if you're using a format like Parquet, where a lot of this information is better summarized. And other than just metadata, and this might be a little bit of an obvious one, leverage partitions when querying. For example, you might only care about the last week of data, so use that filter to kind of focus on what matters. Okay, I wanted to leave you all with one more tip that we found very useful when leveraging job clusters specifically. Unlike all-purpose clusters in Databricks, the default pool size for job clusters is 1. And why this matters is this kind of you can think of it as basically the number of clients. So if you only have one, that can act as a bottleneck. So if you want to scale, one recommendation we have is increasing this, or using a bigger pool. Another consideration is just to leverage SQL warehouses, where some of these metadata queries are not queued at all. Okay, now I want to touch a little bit about Monte Carlo's Databricks integration itself. So that was a lot of stuff to keep track of and manage and build. So we're going to insert a little bit of a shameless plug. We're going to talk a little bit about Monte Carlo. We provide a holistic, think of a single pane of glass view across all your different data assets. It's similar to what New Relic or Datadog did for application observability, but for what's in your data. We use machine learning to try to understand the normal conditions of your pipeline and raise alerts, insights, and provide various different tools to help RCA. And to help understand context and impact without you having to define anything. And if you want to define specific monitors based on your own business logic, you're free to do that as well. And as you can see here from the slide, there's various different integration points. So we connect at both the code level, the different orchestrators you're using, a transactional database, your warehouses, your lakes like Databricks, your BI tools, and all of that comes into our data observability platform, where you can send it to various different notification channels, like let's say Slack. You can create PagerDuty alerts, webhooks. You can create a Jira ticket when an incident is created, or connect it to a different data catalog. And we try to have a big emphasis on being developer friendly. So we have an API, but importantly here, this API gives you full parity with what you can do on the UI. So anything you can do from the UI, you can do programmatically. And in fact, you can do a lot more through our API. So it gives you kind of like the flexibility to take what's created in the platform itself, and let's say you want to export it, or let's say you want to present it in a different way, or you want to do specific calculations with it, or you want to add new data to it, and you want to insert new sources of information based on some sort of your own pipeline. The API gives you full kind of control and ability to do that. And to make this really easy, we also introduced an API Explorer, which is basically a way to interactively to play around with our API directly from the UI. And this is really a useful tool for experimentation and discovery. So you can quickly test out things, see what works, and play around with it, get familiar with it. And then when you're ready to do so, we have an SDK. And the SDK basically can let you, a Python SDK, which can let you more easily productionize using our API. It does all the things you'd expect from an API, like it handles automatic retries, it takes care of auth, it has native objects, returns, more specific things native to the language, and all that other fun stuff, like uses dot syntax and uses snake casing instead of camel casing, because our API is GraphQL based, and Python likes snakes, and a bunch of other stuff like that. It also has a bunch of common features put together to make things a little bit more convenient. So let's say you want to interact with circuit breaking, or maybe create PII filters or something like that. It has a lot of convenience tools to make that a little bit easier. And both the API and SDK power our CLI, which is basically a tool you can use to do multiple different things. One of the most popular ones is actually monitors as code and notifications as code. These are infrastructure as code capabilities for managing your monitors, which is like your different data quality tools, and notifications, and like where these route to. This is important because if you're familiar with an infrastructure as code tool, like let's say CloudFormation or Terraform, this allows you to kind of manage things with revision history. You can see and audit what happens and what changes are made, and all those different things you get from using one of those tools. You can add this to your CI/CD pipeline, or you can create Git PRs, and you can see exactly what changes are made before they're made. The CLI also empowers a lot of other functionality. It helps with discovery. You can use a lot of the insights we generate. One option is, for example, to use like a Snowflake data share if you're using Snowflake, but for other warehouses, you can have the data directly sent to S3 or locally, and you can kind of ingest it into your warehouse. Let's say create a Delta table in Databricks. Like I mentioned, discovery is another aspect, adding different integrations, as well as managing them, managing the data collector, which I'll touch on in a little bit, and a bunch of other functionality. In addition to that, there's also an Airflow provider, which kind of is used, and again, this is built on the SDK, so it's turtles all the way down. It kind of makes it easier to perform some common operations, like I mentioned before, circuit breaking, or also to get insight into Airflow. So you can do things like kind of get more of that context of what's going on if you're using that as an orchestrator. And of course, we also have webhooks, and webhooks are a great way to kind of be notified about incidents. So of course, you can get Slack messages, you can get pages, you can get emails, or whatever notification mechanism you prefer. But webhooks give you that flexibility to make programmatic choices based on the results of an incident. So let's say you want to have a specific set of operations occur if an incident happens. Webhooks are a great way to do that. Or let's say you want to integrate with another third-party tool. Webhooks are another mechanism to do that because you can take the payload, transform it however you like, or interact it with how you prefer, and send it in near real time as an incident happens. Okay, so now let me briefly walk through the collection. So like I mentioned, we connect to a bunch of different resources or assets. Here on slide, you'll see a few different examples of them. So there's data warehouses, data lakes, BI tools, and your various different orchestrators. All of this happens primarily through an agent or interface we refer to as the data collector. It collects a lot of this metadata, metrics, stats, and aggregate log information. And it's basically our primary mechanism between our monitoring system or platform and your data resources. And there's multiple mechanisms for you to kind of manage the data collector. So first, if you don't want to manage the data collector at all, and you can think of it as a fully SaaS product, we'll take care of hosting that for you. So it's kind of gone. You don't need to think of the details of the data collector. If on the other hand, you prefer to host it, you are able to deploy it into your cloud or into your VPC, so you can manage it and connect to different resources how you prefer. Like you can, of course, set up with private link, you can peer, you can kind of do whatever you like. Regardless of the choice you make with the data collector, what we have after that is kind of our data monitoring system. And this is powered by the more traditional tools you'll expect, like you'll have Elasticsearch for search, you'll have a database that backs this up, and different storage layers. In addition to that, we use Databricks as one of our tools to help with analytics and detectors. So we not only build integrations for Databricks and dogfood it, but we actually use it to help power the product. So obviously, we're big fans here. So all of that comes back to that data monitoring system, which helps power the data reliability dashboard. So that you can think of as the main UI. That's all the fancy little buttons you get to click. The reporting system, which is all the different tools to send notifications that I mentioned, like Slack, email, Teams, PagerDuty, and the different programmatic tools like our API, SDK, CLI, Airflow, and so on. So now let me touch a little bit about Databricks specifically. So I want to talk a little bit about the metadata collection, and I want to talk more specifically about the cluster approach. We do have multiple approaches for how to collect metadata. We can leverage SQL warehouses, which is a little bit simpler and kind of more akin to how we deal with traditional warehouses, but I wanted to touch on how we take the cluster approach. Both are perfectly valid to do, but let's say you're going with this option. In this case, you would leverage either our CLI or UI, which connects again to the data monitoring system, just to integrate. Once you do that, we schedule a bunch of different jobs, again, all through the data collector. And this touches and connects to the various different components that you want to be monitored. So let's say it connects to Databricks. If you're using that, it's like using a Databricks Metastore or UC catalog. If you're using an external Metastore like Glue or Hive, you can connect to that too. If you want to connect to the storage layer, it does that as well. So specifically with Databricks, the data is pushed back to the data monitoring system directly, but otherwise for the other ones, it kind of routes through the data collector. And specifically what the data collector does in this case is it provisions a couple of different resources like a notebook, a workflow, and some scope and secrets. It kind of automates that whole process for you through our CLI or UI. If you prefer, you can obviously deploy all those yourself, but regardless of the choice you make there, what happens is basically that workflow is scheduled at a specific cadence, and then data streams back to MC for us to kind of build the insights and do the various detections and all that other stuff we do. And here's a quick screenshot of this in action. So just on the left, you can see our connection wizard. Basically, you just give some very basic information like what's the workspace ID, what's the URL, and a couple other details like that. And you click connect. We validate to make sure the connection works. Like we test to make sure permissions are correct. We test to make sure reachability and connectivity can be established. And if not, we give you actionable next steps to kind of to fix those issues before you connect. Once that connection is made, kind of the jobs get automatically kicked off. And these are these automatic out-of-the-box jobs. And you can always opt in to create other custom monitors as well. And again, you can do this through the UI. And then on the right, you'll see an example of doing this through our CLI. If you're a programmatic fan like I am, that's an option for you as well. And I want to quickly touch on an incident in action. So let's say an incident does get fired off. Let's say you got that Slack notification that that something has changed. So what we do is we have this portal called Incident IQ, which kind of summarizes and contextualizes all the different tools and the different things we talked about. So it takes, like, let's say takes the data from Git, let's say you're using dbt, using Airflow. It kind of coalesces all of that, as well as previous incidents and a bunch of different tools for helping you debug and kind of root cause analysis, like automated queries that that you generate it so you can triage different things, samples of the different data and how it's changed and all that other fun stuff kind of is all in one place to kind of make your TTR process a lot quicker. Specifically for Databricks, we also provide an integration to your Delta history. And what this does is it basically on the fly pulls your Delta history for the specific table that you're investigating. And this is really useful for trying to figure out what if a change happened. Let's say like a specific user was writing at a specific schedule, maybe that write got skipped. Or maybe a specific number of bytes on average is about the same, but that drastically changed. Or maybe a new user was introduced. This can kind of give you that picture, and so you can like piece together when you're playing detective what happened a little bit easier. And then I wanted to talk a little bit about a customer story. So obviously we have a lot of customers using our Databricks integration, but Comcast Effective was able to leverage our data observability product for their Lakehouse. So Effective is Comcast's internal data product and monitors media campaign performance. In fact, they use Monte Carlo to monitor campaign pacing performance data. And this data collects daily impressions for active campaigns. So if a data issue occurs, it's, revenue and reputation at risk. So if you look at this visual, you'll see obviously Databricks is all over the place, and you'll see that data is streamed in from various different endpoints like Lambda, Kinesis, so on and so forth. But with Databricks, Unity Catalog, and Monte Carlo, we're able to help drive data governance, kind of following the standard medallion pattern you'd see with like bronze, silver, and gold tables. And when data is ETL'd, it's available in UC. And there's multiple downstream use cases because you have like the internal applications, the BI reporting tools, different analytics, external partners, and all of that other stuff. And kind of from ingestion, transformation to data sharing and reporting, kind of MC sits there and kind of observes that entire pipeline. So this is what I mentioned around kind of the end-to-end or single pane of glass visibility. It's from all across. That's kind of a quick summary of a customer story. And with that, I wanted to thank you for your time. And if you have any questions, we're happy to go over them.
Yeah, that's great and incredibly detailed. And I would encourage everyone to, if you want to see even more detail, there's an incredible collection of documentation on the Monte Carlo site, docs.getmontecarlo.com. It has all the things that that Prateek was talking about, including a bunch of quick start guides and data lake integrations, data warehouse integrations. It goes all the way down into the API and the SDK as well. So by all means, if you want to take a self-directed deeper dive into some of the docs, that's all available online. But I had a question, kind of a higher level, which is how should people think about monitoring source systems to just simply stop bad data from getting into the data lake, the data house at all?
Just like with software engineering, and I know I've already touched on that point before, not all issues can be prevented, but the more observability you have, the better off you are at being able to quickly identify and address problems as they come up. That is not to say that there are no ways of preventing kind of bad data from coming in. And whenever you have that sort of opportunity, we would definitely recommend that you go about it. But it kind of reminds me of a different question where people often ask if isn't testing enough, right? Like, can we just have, in software, unit tests and integration tests, and same goes for data. And I think for both software and data engineering team, it's not really practical to imagine every possible scenario in which software or data may break. And so while you're definitely going to cover your code and your data pipelines with testing, you're also going to want to have observability, like we touched on with software, it's metrics and logs and traces, and we touched on the 5 pillars of data observability. And so you will definitely put up prevention mechanisms, and you'll try to prevent data from bad data from coming in, or from from data incidents from even happening in the first place. But also you want to be realistic about the fact that it is going to be an uphill battle to really prevent 100% of issues. And so you want to be able to do both. That is the way we're thinking about it.
I'm curious about why you need to integrate, why you need to integrate with other systems. If the Lakehouse is the source of truth, can you just focus all of your monitoring efforts there?
Yeah, I'm happy to field this one. So if the Lakehouse is your source of truth, that's definitely a great place to start. You can absolutely get like a ton of ROI from introducing observability into the system that's kind of responsible for the transformations you do, or the platform for where your data is actually being used. But integrating with other systems is kind of important because very rarely does your data live in a vacuum. This is especially true kind of if you're using some of the popular tools like, let's say, dbt or Airflow. The additional context from those sources can be invaluable in root causing a data incident, like I touched on a little bit ago. And if you don't use any of these like vendors or tools, your code still kind of has to live somewhere. So connecting at least Git, for example, can be very useful to determine like if a particular change was caused an incident. And it can also just be useful for discovery in general. And of course, you also have downstream consumers, because otherwise, why are you building a data platform in the first place, right? You need to have someone using this data. So knowing who those consumers are is very useful, let's say, when communicating or planning for changes, maybe determining the importance or impact of a different issue. Again, like we talked about with Lineage, this context is very, very important in making decisions.
Yeah, so how would you approach monitoring more unstructured or semi-structured environments? And the example they're using is S3 with a Glue meta store.
Yeah, I'm happy to do this one too. So generally, I think when it comes to the core pillars we talked about, or those tenets like freshness, volume, and lineage, there's a lot of overlap between unstructured and semi-structured environments. This is because a lot of your observabilities really can be metadata or log driven, which is kind of agnostic to the data itself. It doesn't really matter how the data is formatted to, let's say, get freshness. Um, though with Lineage, column level connections or relationships might even be more important than they were for unstructured or semi-structured versus more structured data. Though for some of the other pillars like quality, creating monitors, the types of queries you kind of create will require some consideration into the type of data you take. You might need to take account nesting, for example, when you're creating complex filters or something like that. And with schema, like I talked about, you probably want additional monitoring for these unstructured fields, so you can kind of get a better pulse of changes. So you don't just care now about the structure, the specific field changing, like let's say the field name changes. You also want to know what's happening inside the data. Like, so let's say it's a JSON payload. You want to know when a common key goes missing or a new unexpected key gets introduced. So generally, the TLDR is a lot of it is the same. There are some specific actions you want to take if you want further insight.
Yeah, another kind of more technical question with regard to PySpark and building custom data monitors. What are some effective use cases that you've seen with regard to that?
Yeah, I can take that. So, I mean, before we kind of dive into our use case, PySpark is just generally an easy to use interface for Spark SQL. And as software, and coming from software engineering background, we can definitely appreciate how easy it is to use and write more reusable and modular code. So we're big fans, and we've actually built a substantial part of our data platform using PySpark. But there are also interesting kind of monitoring use cases that we were able to implement with PySpark. We call these circuit breakers, and these basically stop pipelines when something kind of doesn't check from a quality or integrity perspective. And essentially that means you want to pause the pipeline, and you want to have someone kind of assess things before you let things resume. And so PySpark is super useful for introducing these checks within your pipelines. I do want to call out one thing to kind of keep in mind, it definitely gets tricky to circuit break reliably at scale without creating a lot of noise for your team to triage through. And so you want to be careful about it. And then again, that's why observability is necessary, because if you try to prevent 100% of things that might go wrong, you might actually create more work for your team. And so we found it actually to be a super useful capability. But you do have to keep that in mind as you're kind of building these circuit breakers into your pipelines.
Well, that's great. And thanks for the answers. And again, I would encourage everybody who has more questions, if you want, you can go check out all the things that are available on the Monte Carlo website, but also reach out and engage. I mean, that's honestly the best way for you to understand your specific, unique situation and how Monte Carlo can create these types of solutions for your situation. Before you leave, though, I do want to point out something that you guys have got coming up that we wanted to get to, which is your Data Observability Summit Impact, which is on November 8th, 2023. And I'm sure both of you guys will be participating in that. Anything you want to add with regard to kind of the value that you've seen coming out of that I know you had one last year as well. What can people look forward to there?
Yeah, no, it's we're actually very, very excited about it. Last year, we've had some amazing speakers. One of my favorites was Nobel Prize winner Daniel Kahneman, and I don't have all the secret details yet for the upcoming one, but definitely very excited to see how how we line up like great speakers and great content for this. We hope to see you all there.
Yeah, and the URL is impactdatasummit.com, and you can register to attend that. This has been great. Always love to see a really detailed presentation like that. Thank you very much for going deeper into the Monte Carlo solution and everything that you can do with data lakehouses. Clearly, you guys have a lot going on. Best of luck for the rest of the year and the Impact Summit. And thanks very much for being with us today.
Thank you, Doug, for having us.
Thank you for having us.
Well, there you have it. Another solution in our spotlight. We want to thank Prateek and Itay for that fine presentation. And we appreciate your attendance as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.